Traditionally, submerged arc welding is executed as a machine or mechanized welding process, meaning the welder observes the welding process and manually makes adjustments. Today we're going to talk about LJ's adaptive welding technology, where we're programming and automating some of these parameter adjustments in order to achieve productivity and quality gains. There are several efficiency gains that you can benefit from. The new adaptive welding system uses high-speed controls to adjust welding parameters in real time, faster than a welder could. This allows higher travel speeds and lower cycle times. By automating these adjustments, human error and operator-to-operator variation decrease, reducing defects. Automating repetitive aspects of your welder's job reduces fatigue and frees up their attention for other value-add activities, increasing their productivity, ultimately helping your bottom line. There are several resource savings that you can benefit from with this technology. Depositing the precise amount of weld metal for the required profile and penetration depth reduces waste of weld wire, flux, and even electricity consumed by the welding process. By assuring a consistent first pass penetration depth, the second side can be welded with confidence without gouging or significant preparation for 3/4 of an inch and thinner prefabs. By reducing weld repair frequency and ensuring first-time acceptance, fewer X-ray hours are required. There are several strategic ROI improvements that can be expected from the implementation of this technology. Those include reductions in labor costs, consumable costs, other inputs to the welding process, which will result in bottom line savings for the prefab pressure retaining welds that you execute. The adaptive welding technology that LJ is developing currently is expandable. We can use this same basis for other welding applications, other joint configurations, etc. By being the first to implement this automated welding technology, you can maintain a competitive edge in the North American manufacturing industry.
Okay, so this is our welding setup where we've got a very tight joint at the beginning of the joint, and as the joint progresses through, we go from a very tight root opening to a larger root opening of about 50 thousandths. And within this joint, we also have tacks. So when the laser scanner sees a tack or sees the root opening adjust, it will send that information to the HMI, make the adjustments to the parameters, and so as we weld, we'll be able to see it go back and forth between different parameter sets that are the most optimized for that area of the joint.
Okay, welding.
So the weld's initially going to fire up, and we're about to go over a tack section, and you'll see it adjust those parameters. Once we move off of that tack, you'll see it adjust back to a different parameter set as we go throughout that weld. Right now we're in a section of the joint that's not tacked, and we'll move again once we get to about right here, and we'll change it to a parameter set based on the tack that it's seeing. It's currently welding over the tack. Now it's off the tack and continuing to progress, and we're approaching the end of the joint with the wider root opening. So we're about to start welding side 2 of the joint, where we've taken the plate and filled the groove up, and now we're going to flip it over and weld side 2. There won't be any parameter adjustments throughout this, since we've controlled the penetration on side 1 to get to that same point regardless of how the joint changed. And so we'll use one parameter set throughout the entire length of this plate to complete a weld without defect that will pass X-ray without a problem. You can see that as it's going through, we're still using the servo robot to be able to adjust the weld height and track the seam, but we're not making any adjustments on that HMI. We're staying steady with one set of parameters. The only thing that allows us to do that is the accuracy of control that we can have over the joint on the parameters on side 1 to control that penetration and put it at the same point no matter what.